Alright, welcome to our notes on what is a function. So we are starting the second unit, which is all about functions. So you might have heard the word functions before, but now we're going to talk about what it means. But first we have to talk about the word relation. So this says, by definition, a relation is. So in math, the word relation means anything that relates x and y. So think for a minute, what can you think of that relates x and y in math that has both an x and a y? Well, graphs have x and y's. Tables have x and y's. And equations have x and y's. Alright. Now, that means that most things you see in math are relations. But these notes are about what is a function. Well, by definition, a function it's a relation, but it's a special relation. A special relation where for each x there is only one y. So that's the important part. For each x, there's only one y. So, we need to talk about this concept not in math. So let's talk about someone's age. Let's say we have a function machine. So it's a function machine. And in this machine, we put in someone's age. Or we put in a person. So in this machine, we put in a person. And then the machine will tell us their age. So in math, x is what we put inside, and y is what we get out. Another name for that is x is the input, the thing we put in, and y is the output, the thing we get out. Okay? Well, it's important then that if a function machine is an age machine, if I put someone in, like let's say I put in person number one, into the machine. And let's say it gives out that they're 17 years old. And then I put in person number 2, and I get out that they're 18 years old. And then I put in person number 3, and I get out that they're 17. It is okay that I got the same answer, because it's okay for two different people to have two different ages, right? That's totally fine. What's not okay is, let's say I put number 1 in again, and then suddenly it gives me out 20. Well, this is a problem, because I put in the same person and it gave me a different age. A person can't have two ages. So for each x thing we put in, the thing we get out, the y, each x can only have one answer. So if I put in a person, I can only get out one h. When I put in an x, I can only get out one y. So let's talk about in a table something that's not a function. Something that's not a function in a mathematical table. Remember, your x's go on the left and your y's go on the right. Let's say I put in the number -2, and whatever the machine does, it gives me out the number 1. And then I put in, let's say 0, and whatever this machine does, it gives me out a 2. Then let's say I put in 1, and whatever the machine does, I get out a 1. And that's okay so far, because it's okay that these two x's have the same y. But if I go and put in -2 again, and then let's say I get out 0, now I have a problem, because this -2 went in and got out 1. And then I tried doing it again, and it went in and gave me a different answer. And that's not okay. That is not a function on a table. However, a table that is a function, x, y, let's use the exact same table. -2 gives me out 1, 0 gives me out 2, 1 gives me out 1. But then this time when I put in -2, I should get out 1 again, like I did the first time. And that makes it a function. Okay? Well, on a graph, let's draw a graph. Alright. So on a graph, let's say I put in 1, and this is my x. So I put in the 1, and I get out 2. That's good so far. Let's say I put in -2 and get out 0. 0 and get out 0. That's okay for these two to have the same answer of 0. Don't forget this is your y. I didn't write it up there at first, but it's your y. But let's say I go in and put in 1, and this time I get out -2. This is a problem. These dots right on top of each other is a problem because right here x is 1. When I find the dot where x is 1, there's 2 of them. There's the one at 2 and the one at -2. And this is a problem. It's not a function because for functions, each x can only have one y. And right now, the x of 1 has 2 y's. So a graph where it is a function just means for any x, there's only one y. Now it's okay for this x, the x of -1, to have the same answer, 2. It's okay for them to be side by side. It's not okay for them to be right on top of each other. Finally, for an equation, there's no special way to know when it's a function and when it's not a function by you just looking at it. You would have to plug in every single x in the entire world to figure out if it gave you more than one answer, which is a lot of work. So basically, here's what happens. If it's not a function, or if we don't know, they just put y equals, let's say it's 3x plus 1. However, 3x plus 1 actually is a function, and I know that because I've seen it proven to me. And so when something is a function, to let you know that it's a function, instead of y, they put this symbol. It's called f of x. So you don't say f times x, it's not being multiplied to it. It's its own little symbol called f of x. And we put that there instead of y. It just means y. It just means output. But it's how the mathematician who proved this was a function lets us know, hey guys, this actually is a function. So what is f of x? What does it mean? Well, the f of is a name. Like if I just looked at the class and said, what's your age? Who would respond? Probably everybody, because you don't know who I'm talking about. So the f is its name. So f of x means it's a function. It is a function whose name is f. Okay, so then what's the x? The x is what we're plugging into the function. The x is the input. So we say whose input is x. Right? Because x is what we put things into. However, also f of x is just y. So under this one where it says what is f of x, the answer is y. It is the same thing as y. This is the fancy mathematical version, where it technically is a function whose name is f, who has an input of x. So, With f of x, it doesn't have to be an f. So to the question, does it have to be an f? No. Because remember, f is just the name. So it could be any letter we want. We can call it function A, function B, function C. It doesn't matter. It's just a name. So it can be any letter. It can be any letter. In the same way, for does it have to be an x, the answer is also no. X is the most common letter we use to mean input. However, for example, if it's a word problem about time, often you'll see them put a T instead of an X. Any letter just means something we don't know. So we can use any letter to be the input slot. Because it's just saying this is where we put things in and we don't know what it is and we can change what it is. So in the same way, anything can represent input. We just most commonly use X. So if we go ahead and flip this over, often when they ask you if something's a function, there's a couple other questions they end up asking you, specifically about the x-intercept and the y-intercept. So this little paragraph says when we're looking at mathematical relationships, equations, tables, and graphs, there are special details about them that we often care about. We use these details to describe the situation. So often, they're going to start in math asking you to describe situations and what's going on. And this is a really common two descriptive words, the x-intercept and the y-intercept. So x-intercept means cross x. So it's where the equation crosses the x-axis. So, in a graph, I have my x and my y, and let's say it crosses, let's go 1, 2, 3, 1, 2, 3, up 3 on y, down 3 on y. So these are my tick marks. And let's say my graph crosses, it has a point right here where x is 0 and y is 2, right there. And let's say it also has a point right here. So on the x-axis, the third tick mark. And then it's a graph, so let's make it a linear, a straight line graph. It looks like this. For this one, the x-intercept is where it crosses x. So this is where it crosses x. So this is the x-intercept. X-intercept. Okay. Well, if I'm listing that point, remember a point is always the x, comma the y. And x is hard-forwarded left or right. So from the middle, I went right 3. So my x is positive 3. And then my y is up and down. And from the middle, I went up. From the middle to get to this point, though, I'm talking about this point, I didn't go up or down at all. So for this one, my y is 0. So for this point, my x was 3 and my y is 0 because I didn't go up or down at all. So this brings us to a very, very important fact, because if it was right here, the x would be backwards too, but the y would still be 0 because it's not going up or down. If it was right here, the x would be negative 3, but the y would still be 0 because it's not going up or down. If it's on this line, if it's on the x-axis, it's not going up or down at all. So for x-intercepts, there's a special rule that says y always equals 0. So if it's an x-intercept, it means y equals 0. So that means if I had a table, let's say this is my table, x, y, -1, 0, +1. Let's say it's 0, 2, 4. Well, remember the rule that I just told you, that the x-intercept for x-intercepts, it's not going up or down at all, which means y is always 0. So in my table, my x-intercept is this point, because this is the point where my y is 0. So this is my x-intercept. So in the same way, in an equation, let's say I have y equals 3x plus 1. Well, if I want to find my x-intercept, it means I make y 0. Because for x-intercepts, y is 0, because it's not going up or down at all. So that means I make y 0. And I have to solve for x, which you did in the last unit, to figure out what my x is. So I'm going to subtract 1 from both sides. 0 minus 1 is -1. I bring down my 3x. And then over here, plus 1 minus 1 eliminates and becomes 0. Then, to get x alone, I need to divide my 3 away. So I'm going to divide both sides by 3. So I find out that right here, because I can't do -1 divided by 3, my answer is actually just -1/3. Equals, and on the other side, 3 divided by 3 was 1x. So it's just x. So my x is 1/3. So my point for my x-intercept, my x comes first, always. So it's -1/3. Comma, my y, remember the y I plugged in was 0. Because for x-intercepts, y always equals 0. Alright, so then the next key feature on a graph that's really important is called the y-intercept. And the y-intercept is where the equation crosses the y-axis. So, I'm going to draw the exact same graph. So x, y, 3 tick marks in each direction. A point where I am 3 to the right, but don't go up and down. Then on y, where I'm up 2. Connect my points to make a line. So in this situation, for the y-intercept, it's where it crosses y. So it's this point right here. That's the y-intercept. Okay? And if I'm trying to list that point, remember a point's always x comma y. So the x, how far from the middle, how far left or right did this point right here go? Well, none at all. It's on the line. It didn't move. But it did go up 2 for my y. So that's the up 2 there. So note that y-intercept is on this line. And if it's on this line, it never goes left or right. Because it's on this line. So it never moves from the middle left or right at all. It just stays right here at 0. So for y-intercepts, x is always 0. So I'm going to add that note that x is always 0. Okay? So for the exact same table, if I copy it, x, y, -1 and 0, 0 and 2, 1 and 4. My y-intercept is where x is 0. So x is 0 right here, 0, 2, and that's my y-intercept. And then if I use the same equation, y equals 3x plus 1. For these guys, it's where x is 0. So instead of x, I'm going to put parentheses 0. And now that means 3 times 0, which is 0, plus 1. So y is 0 plus 1. So y is 1. So the point, though, the y-intercept, remember the x we plugged in was 0, and the y that we found at the end was 1. So this is our y-intercept.